Good morning, everyone. Can everyone hear me okay? Am I too loud, too soft? Perfect. Just like Ray said, thank you for coming. Appreciate everybody attending today. Hope to put together a good presentation for you here. I'm not a very experienced public speaker, so bear with me a little bit if I kind of miss some steps, but I hope to put something together that you guys can understand and appreciate. We're going to talk this morning about duct leakage testing. General term in the AABC standards is leakage testing, because it's not just ducts that get tested for leakage, it's casings, floor testing, building pressurization, stuff like that. So first off, we start with leakage testing as a key component. Helps us save energy, helps us reduce the cost of operating the building. All those are relative. Has anyone here never performed or witnessed leakage testing? Has anyone here performed leakage testing and witnessed it? Great, that's pretty much everybody in the room. So we're not talking foreign languages here, we're all on the same page. When we can get leakage testing performed on casings, air handling units, filter banks, ductwork, it definitely provides the job with a much better return outcome. It provides the owner with something much better and a return on his investment down the road. We're going to, look over the methodologies, industry standards. Is everybody aware of the AHRI standard for casing leakage testing? It's pretty much the same thing that SMACNA puts out. They actually reference SMACNA. And then is everyone familiar with the AABC standard on leakage testing? Raise your hands if you are. Good. We're going to talk about it a little bit today. I have a couple case studies, and I'm sure everybody here has experiences in in-house and in-field testing where you've had experiences where what they said at the manufacturer for an air handling unit and it's supposed to leak, then it got put out in the field, failed miserably. Everybody stumbled and pointed fingers back and forth as to who did what wrong and why is this unit not operating and failing its leakage test. So we'll discuss some of those. This is a guidance for engineers, commissioning providers. Of course, there's your AIA credits, copyrights. Like I said before, this is basically a discussion on Chapter 5 of the AABC standards that came out 2 years ago, something like that. And it's a good practice. Leakage testing is all about, in my opinion, quality and integrity. If you got the integrity team put together that's going to be diligent in making sure leakage testing gets done on whatever project or retro project you're doing, the quality will follow, and then there's not much bad that can happen from that. We got 4 learning objectives. Specifications, specified in both tab and duct construction specs. How many people have read a spec and said, well, we don't know who's going to witness this or who's going to perform it? We know it's there and they have the standard, but we don't know who's going to witness the test and we don't know who's going to perform the test. And then it becomes, again, balancer, you need to go out there and bring your equipment and test it, and then it fails and you go back and forth a dozen times until you get there. But it's probably a best practice to have the installer test it and have the testing company with maybe the commissioning agent or the engineer or owner's rep on site to witness it, and we leave it up to the balancing agency to record it. So brings everybody together, makes a team effort, brings that integrity and quality where we are. The duct construction is can be many levels depending on what kind of duct it is, but again, that needs to be brought about in a fashion to say this is how we want it constructed and we don't need it compromised. Testing methods. Now this is in-field versus in-house lab processes and environmental impacts. So the in-field and versus in-house, we've had units put together in the AHRI environment at Carrier or Train or Buffalo or Dakin, and they all pass perfect. We get a letter that comes with the submittal. This unit's been tested, sent out the door. Now you guys put all the pieces together in your modular unit, and it fails. Well, the in-house testing cannot be replicated in the field, just can't be. There's too many environmental changes, there's too many instances of, just 2 months ago we had one at University of Maryland where they put a unit in right up against a wall. So we had the housekeeping pad and the wall that once it was installed and all put together, if that side leaked and the horizontal on the bottom leaked, you couldn't get to it, you couldn't fix it. It was about the integrity of putting it together. So it's very, very difficult to replicate in-house or in-lab processes. It says environmental impacts there, which I'll talk about a little bit, but we'll probably talk about it again. It has to do with mastics. Duct construction out in the field, units, put them together. We've had projects, and I'm sure you guys have been on them. I live in a cold climate, seasonally, Maryland. Some people never have this problem where it freezes, maybe sometimes in Houston or Florida once in a while, but they hang the ductwork, they put the mastic on, and it doesn't have all the branches hooked to it, so it's a trunk line. And as it's cold on the deck, they put all the mastic on, and that duct does the wiggle, right? The wind's blowing or somebody touches it, so every one of those seams cracks because the mastic dried or it froze. We pressure test it, it leaks. How's it leaking? So you put everybody's eyes and ears on it and go, oh, it's leaking there, it's leaking, oh, all these things are cracked. So it's definitely a conscious thought for environmental impacts when you're constructing things as to what could adversely affect the outcome. Documentation and witnessing, I just delved on that a little bit. Who here thinks that the installer should perform the leakage testing, witness the leakage testing, and record it? I'm glad no one raised their hand. We have had instances, I was talking to someone last night, where they wanted to test it, send us all the information. Someone told me they were taking pictures of gauges. They sent me a picture of the gauge and it passed, so we all certified it. And I was like, was the guy just blowing in the tube to make the gauge? Put eyes and ears on everything when it comes to witnessing and documentation. And like I said a little bit when I started, was the integrity and quality of the job. I'm going to say that a lot. Bring about the team method, the team manner that you go get the job done. If you have that team energy, if you will, the installer will be held to accountability. Energy savings, the cost for proper install and sealing versus lifelong leakage. We've all had many stories of how these buildings leaked for years and years and years, and we show up in a retro. Oh wow, your ductwork's leaking 20%. Well, it can't be. Well, it is. We had a job years ago, 9-story building, L-shaped. We had 2 units per floor, self-contained condenser water. They were Bone units, B-O-H-N. I don't know if anybody remembers those. I haven't seen them in years. But anyhow, they were burning up 1 compressor in each unit every week throughout the entire building. At least 1 compressor would go out. Well, it was leaking so much air above the ceiling in the return plenum that the return air plenum had colder return air than the space. It was subcooling the return air. So the unit would get its return air sensor, shut the compressor off. About 30 seconds or a minute and a half later, the unit would start back up, compressor would come on. Well, this thing started and stopped like 1,600 times in a week. Throughout the whole building, these are going on. And they had them sitting at the loading dock with these compressors ready to go in, up on the elevator, change them out, put another one in, and you were like, good God almighty, how long have you been doing this? Oh, the past 9, 10 years. Wow, we just think they're faulty units. And we were like, nah, let's seal 1 ductwork, 1 system. And it took them about 3 months to fail a compressor, but those compressors already had hundreds of thousands of hours on them, so they were in ultimate different points of failure. So the energy savings that you can get out of duct sealing it pales in comparison to the small cost of providing duct sealing or quality installation. Everybody knows the formula, CFM to the cube root of the horsepower. Everybody understand that formula? So just do that simple calculation in your head. If, we could save 10%, 15% airflow in a unit from leakage, think of the horsepower savings. It's not a complicated formula. Standard methodologies. I talked about it a couple minutes ago. AHR and SMACNA standards are relative to providing leakage classes based on pressure and surface areas. Everybody understand that with the length, width, surface area of whatever unit you're dealing with, whether it be an air handling unit or ductwork. And they put you in a certain class and say, all right, you have this many square feet, you're allowed to leak this many CFM per 100 square feet or per square foot. Multiply it times how many square feet of ductwork or unit you have, and that's your allowable leakage. The AABC standards are relative to percentage of air quantity. Now, I've had a couple people, more than a couple, but we'll just say a couple. We have a big riser in a building, right? So the first floor, of course, gets 60,000 CFM. And then we have branch offs, and the fifth floor gets 50,000, and the next one goes down 40. By the time you get to the lower floors, this main trunk is only really using 10, 15,000 CFM. So they wanted to test it in those sections so that they didn't have this big thing to test. That would bring them down to where they had a little bit more allowable. That's not what the AABC standards are all about. It's about system testing, not parts of systems. The AHRI standard, this was September 15th. This is the SMACNA duct air leakage test manual. Has everybody seen that, witnessed that, looked through it? Raise your hands, anybody who hasn't seen the SMACNA manual or looked through it. Well, that's good, most everybody has. Sometimes you stand up here and you think you're talking Greek, and they're like, well, what are you talking about? This is the SMACNA leakage classes. That top line there, I think you all can see that. We have seal class C, B, and A. Of course, transverse joints, seams, and then A is absolutely everything. So A is basically what you want to shoot for when you're on any job, in my opinion. If you start shooting for other things, it just leads you down a path of terrible results. And it's not that difficult. And then you have at the bottom leakage class based on rectangular and round metal. So if we go beyond that, the SMACNA appendix, they're going to give you a leakage class on the left-hand side. Of course, the top class there is 48. That allows it to leak the most. If you look across there, you'll see half, 1, 2 inches. There's numbers out there in the middle of here. If I can point this, all these numbers right in here, they're all percentage of leakage. So if you looked at something that was in the 48 or 16, if it gets to 2 inches of static, they're allowed 38%, 19, 15, 9, 6, and this is where it starts getting lower down in here because the leakage class rate goes up, and they, get down into here, we're at the 2%, 1%, 1.5%. In the middle here, we're at the 6s. So depending on what leakage class they put you in, allowed to leak more. And this is a chart just explaining what their criteria is now. If anybody can back me up here, I think this is a 2012, if I recall. And this is a little more stringent than it was previous to 2012. Does that sound right to everyone? So I know the more they had years ago on that chart, the more they allowed leakage. Anybody have any questions about the SMACNA way, or everybody kind of understand? I don't want to be droning on about it and then everybody's like, hey, we know what you're talking about, stop. So getting into the AABC Chapter 5 about duct leakage testing. I know I said leakage testing before, but it does differentiate between duct leakage testing and air handling unit testing. So engineers and commissioning agents and owners and everyone in here understands it's not really a part of the total system balance. So if you were to say provide balancing per total system balance, you really have to call out what you want for duct leakage testing. This isn't really a part of it. It's kind of like you have to call out the chapter or call out the specifics of what you're looking for. AABC recommends that the leakage testing be specified in both the testing and balancing section as well as duct construction. I just talked about that a little bit ago. Everybody understands why that is, so that there's no finger pointing back and forth about who's responsible. Contractors responsible for construction, the sealing of ducts, their responsibility to prepare the system. We oftentimes have the installer pre-test the ductwork so that when the owners, commissioning agents, balancers all show up to witness it, there's no failure rate. They all look good and they move along. We've actually rented our machine out quite a few times in the past couple of years to installers to, here, you don't have one, but use ours and please get it done right. It helps everybody at the end. The tab agencies shall provide the calibrated instrumentation to be an independent witness to the testing. That's part of the chapter overview. That is exactly what we do. It never hurts to provide assistance to the job with your calibrated instrumentation, help the process go along. Of course, there's some liability there that we all don't want, but sometimes we have to take it. Duct leakage reduces the air quantity in system to the terminals, should be minimized. Excessive leakage will increase the fan speeds to compensate for the reduced terminal airflow, therefore increase energy use over the outcome, to overcome the leakage, I'm sorry. Many times you get involved in a system and it's 20,000 CFM, the unit's only putting out 18 or 17 to the diffusers, terminals. You get to the CEO's office is always at the very end, the last one, can't get the air to it because it's all getting robbed, and now we've all of a sudden created diversity in the unit. There's no more horsepower, and if it would have just been sealed correctly or sealed better, the CEO wouldn't be involved in what's going to happen next. Excessive leakage can make balancing a terminal's distribution system to the design criteria often impossible. We've had more than enough exhaust systems. Get the whole thing done. Systems in, we start balancing it. And where they terminated all the little exhaust grills, they flanged them between the ceiling, and it's compromised right there. Next thing you know, we've got 5%, 10% leakage at every one of them, or the telescopic fittings. The ductwork's all sealed, but then when we get to there, it's important that all the way to the end terminal, like it says here, be sealed and help reduce leakage and shortcomings. Duct leakage occurs at openings in the duct through joint seams. As a result, reduced quality of workmanship. I said that earlier. The quality of workmanship is key. We've had teams where they talk, oh yeah, we put it in, everything's great, and it fails miserably. Just that no one was experienced. There was no quality there. There was no integrity to get the job done the way it should have been done. And we've had other teams that everybody on the job knows is what even the electrician knows. Did you pass your duct leakage test today, or did you pass the unit test? They're all happy because now they can start drilling holes in the unit to put their conduit and sensors and all that stuff. And you're like, wait a minute, you got to see all of them. We just tested it. Now you're going to ruin the compromising integrity of it. So it can get very. The quality of workmanship is key, and I know I've been beating that drum, but it is very key. Leakage rate is a function of the openings in the duct and the static pressure. Of course, as static pressure goes up, you're exponentially going to change your leakage rate. Building codes generally require that ducts be sufficiently airtight to ensure energy conservation and control the air movement, humidity, temperature, and the space. The temperature and the humidity in the space are key. The air movement is in my opinion, a byproduct, but the temperature and humidity control, if you got all that going into the ceiling, it's not meeting the space, you're not going to do the work that you want it to do. Selecting duct construction static pressure class suitable for the operation of the system and specifying the proper sealing of the ductwork can accomplish all this. The AABC recommends that duct systems, including low pressure systems, be sealed and tested in accordance with this chapter as a minimum threshold. That is a basic overview of Chapter 5. You can go to the Chapter 5 standard, read it. You'll get the same thing. I pulled it right out of there. It's very, I'm going to say common sense. This isn't brain surgery. It's, you know, we've all been doing this. It's something you have to get done, and it's about a team effort. Accuracy, repeatability, and integrity for construction and application. We talked about this a couple minutes ago, or I did. Temper and environment not to compromise sealants, application of mastics, construction methods per industry manufacturer recommendations. So when you're doing mastics or you're doing any kind of tape, they have a recommendation for how you should put it on, when you should put it on. Time of year, temperatures, all that neat stuff. They should be followed. They're there for a reason. They know the failures. They know the successes of their material. We talked about temperate environment. So the AABC Chapter 5 has a list, if you will, of allowable leakage, and this is their recommendation. We saw earlier that SMACNA had a list, a little chart. They also have a bar chart. AABC has this list, and the list is basically pointing out, I think it's 10 different systems, types of systems, and I think, in my opinion, I think they're much better, easier to follow than other standards. I think they're a little more stringent, a little tighter. We've had Danfoss. Does anybody here know who Danfoss is? Yeah. We have one of their regional offices in our area, and they put in 32 VRF units above ceiling, and they were ducted. Some of them were only 1-ton units, some of them were 2. Some of them were 3, but they were all small, ducted in everyone's office or this area, and it's a VRF system, so they're trying to get all the efficiency they can out of it. And they called us and said, look, we're ready to do some airflow testing. And they started failing miserably, and we're like, didn't you guys duct leakage test this? It says right in the spec. We know Burdett Kohler Murphy's the engineer, are we? Oh no, these are little, we can handle this. Well, we tore one apart, and it was literally 4 sections of ductwork, slip and drive, leaking 16, 17%. And they sealed it. And you're like, wow, you didn't do what you were supposed to. So next thing you know, they were taking little sections of duct. I mean, we're talking about 3 sections, 4 foot or maybe 5 foot. So we're talking about 15 foot of duct. They couldn't get it sealed. Just, you know, generally putting it in, slapping dope on it, away they go. Miserable. And that, you know, compromised their efficiency going down the road with all their VRF units, thinking, well, we got this thing licked. We're going to have a great system. No leakage above the ceiling. And yeah, talk about 400 CFM on a 1-ton unit or 500. You're leaking 15%, 18%. You got 30 of them. You do the math. That's a lot of air you're not using. Small systems, splits DX were 2%, VAVs, terminal boxes, associated downstream ductwork. When you get into the 1-inch, 2-inch pressure test, everything seems to be staying at the 2% range. And I personally would like to see 1%, but everybody goes crazy when you say 1%, so they went to 2. 2 is a good number. Like, I don't think anybody here could say that's outrageous. Does anybody here think that's a little too stringent? Whew, thank God. Chilled beams. Everybody work with chilled beams? No? Chilled beams are they're a marvel. I do appreciate them. I like them. But if you don't have the air going to them and you're leaking it, they can be a problem. All duct chases, concealed spaces. I hinted on that a little bit ago about that air handling unit up against a wall, but if you have ductwork in a chase and it hasn't been duct leakage sealed, and we get to a point where it's leaking and now we have a problem, we're starting to tear walls apart and get back in there. Supply duct for VAV systems at 4 inches. VAV supply terminal boxes tested with upstream ductwork. These are boxes tested within the system, correct, Galen? While they're connected. This isn't to the inlet of the box. This is to the discharge of the box.
You test it before.
I'm sorry?
You can test it before it's installed, just to make sure the box doesn't leak.
Oh, okay.
Can't test the box.
Right.
You can if your inlet damper seals off to less than 4 or 5 CFM.
On the terminal box, correct. We've had instances where they were bound and determined to get it sealed up tight with the boxes installed, so they did all the discharges. That was a fight, that was a battle, because the boxes leaked more than they ever wanted them to. There I see some guys shaking their head, they've been there, done that. Yeah, and that's a component that's put in there to, and then they put a reheat cool on it or something else, and it's a problem down the road. Does anybody see dual duct systems anymore? New? Do you? New install duct, hot and cold duct. In schools down your way, huh? We don't see them too much. We have one job, it's a lab. Dual duct. Imagine that. High pressure induction systems, I don't see those at all anymore. Does anybody see those? No, but it's in there. Do you see them? Wow. Yeah, I don't see much of that. Are the console high pressure induction? Have you seen any of the witnessing on, have you witnessed any of that leakage testing for that stuff? No. I don't mean to put you on the spot. I just saw you shake your head and I was like, wow, I haven't seen them in years. Anybody have any questions, comments? You want to talk about duct leakage testing or air handling units or duct work?
Go ahead.
When you mentioned about the box leaking, who's responsible for the box, the manufacturer or the installing contractor?
Manufacturer. He's put out a box that's certified, and it's up to them to, you know, we're not there to prove the box. That's already been somewhere. It's basically a piece that's been shipped to the project, not a piece like a unit where it's been shipped modularly and they have to put it together on site. So you'd have to take that up with the manufacturer or the rep.
There's no published leakage rate though.
No.
So that's the big problem.
But it's been put together per a standard. All right.
But then if it leaks
Yeah, there's no,
down to 100 CFM,
right.
there's no published leakage rate.
Yeah, the AHRI thing I read about and the SMACNA was for casings. It really wasn't for air handling or VAV casings. It was for air handling unit casings.
VAV sealing kind of slipped through the cracks because I've noticed a lot of leakage on all the types of VAV boxes. They seem to leak the worst.
We
go through all the trouble to seal the ductwork and make these contractors work their butts off to make it tight. And then they go to the question of the box, and when they go to the ceiling, the boxes are
Yeah. We have a job right now where they have dual duct and the gasketing on the blade, you know, the damper, it's 45 degree. Well, when it goes past that, because they didn't really adjust the damper stroke correctly, it pinched the neoprene, kind of ripped it, so now half of it's flapping. So when it goes closed, we got a mix of cold air and hot air. Yeah, and they're very easy to get to fix. It's like a dream.
One of the things, ASHRAE's done quite a bit of research on the efficiencies of fan-powered terminals. And Title 24 out of California used to recommend parallel boxes. And with all the research that we've done, it has proven that the parallel boxes have backdraft damper that looks like a sieve. And that's something that was overlooked when they said how efficient those boxes were. So it's proven the series box is more efficient than the parallel. And that's all about leakage again. One thing that chart really doesn't point out is if you have a bowel containment system.
Which chart?
That one up there.
Oh, okay.
Where you have high efficiency filters, HEPA filters, you probably have zero leakage requirement on your ductwork at that point.
We've had beware what you wish for, right? So we bid a job, BSL 3, 4. It's an Army Corps of Engineers, wonderful people to work with, and they designed some crazy stuff. Like, you know, I've been around 30 some years and kind of took my breath away. Like, wow, this is really intense. But A lot of 0% leakage. HEPA filters, casings. You know, we were just talking with Troy back there. Jeremy reminded us, this is like 2 months ago, I guess. Maybe 3 months ago. I think it was a Christmas present, wasn't it? The exhaust went so high in the BSL-4 that it collapsed the supply duct. So the room went so negative that it sucked the supply duct, broke it apart. It also pulled all the water out of the traps in the floor, and it hit the ceiling, and all the toilets and whatever, boom, it went up, because this is a BSL-4, everything's in there. I was like, what in the world happened here? What? It was almost like a Ghostbusters thing with stuff falling from the ceiling. Like, what is it? And like I say, beware what you wish for, because it was the neatest job in the world, and now that we've got into it, there's a quagmire. But that kind of stuff is very interesting. That it's just the room is not really a room where we're actually exchanging. It's just a part of the system, the supply and exhaust. It's just another extension of the ductwork. Lots of duct leakage testing up there, more than our fair share. Air handling leakage testing. This is again the AABC standard. Units shall be furnished with proper blank offs to facilitate the pressure testing and around flanged openings of the test orifice. Air handling unit testing is, I'm going to say, subjective to whatever project you're on. There's really no set specific, this is what you do and this is how you do it and these are all the pieces in it, because, as I alluded to a little bit ago, once the electrician gets to that unit and he starts drilling 3/4 inch holes everywhere to put his EMT, and then it goes to all his junction boxes on top of the unit or the side to run all of his control wiring, if they're not sealed off where the little wire goes through to whatever sensor or control device is in there, or the 2-inch hole to mount the VFD on the side of the unit, because that wasn't a provision from the manufacturer. He just drilled this hole, mounted the VFD, now it's on the side of the unit, and you're like, I thought that was getting mounted on the wall. No, we're putting it right here. Wow. So now we have this other hole. Do we do that pressure testing on those casings after all that's done or before? And that's something you need to take up with your owners, commissioning agents, and the team to say, okay, we do all this before, and then the owner gets in there at acceptance and his hair's getting blown sideways because air's blowing out of this junction box or out of the air handling unit where the VFD's hooked up. He's not going to be too happy. Like, well, what'd you guys do to my unit? So very, very, very important to make a coordination effort beforehand to figure out how you're going to test those, when you're going to test them. With the unit set in place, leveled, ready to receive ductwork connections, units shall be tested for casing, leads of a ceiling, all openings, and pressurized in 2.5 times rated pressure, defined as static pressure of a unit, or 10 inches, whichever is smaller. So, with that being said, casings have a unique function as to how they're put together. Some are different than others. Some of them are just flat flanged. Some of them have I'm going to call it a bird mouth, where it goes into one, or a V connection. And they put sealant around there and they put these sections together. And that is part of quality, again. Ready to receive ductwork connections, leveled, placed. Can't stress enough about ready to receive the ductwork connections. We've had them where they had pieces of ductwork on them and then they blank that off. We've had them where they just blank off the end of the unit with a piece of metal, or I've even seen plastic on there. And believe it or not, everybody's seen the blue protective film on ductwork they send out to jobs because we don't want dust inside of it. That stuff actually works really, really well. We did a unit and they just, self-sticking, stuck that right on there. Man, it worked like a champ. It was blowing out. It looked like it was going to pop apart any second, but it actually held. I was impressed. Has anyone in here not done casing leakage testing on an air handling unit? Okay. I've done them on units as big as, half as big as this room. I've done them on units that are as big as the bed of a pickup truck. And they all have the very same outcome. They both failed miserably. I've seen them never pass the first time. I don't know how many people in here can replicate that or can say, no, I've had them pass the first time. They very, very seldom pass right straight away. There's always a door or a leak or a void or a trap somewhere, condensate. There's so many little pieces to an air handling unit. The minutia of that is it's got to be gone over with a fine-tooth comb, and it can't just be generically thrown in as, oh, we're just going to test the casing of this unit, everything will be fine. There's so many little pieces to it. Yes, sir.
It's important to note right there that when we test the unit in a positive direction, we're taping up doors that we subject to negative pressure, and vice versa. So you could fail miserably through those.
So there's going to be a little controversy. There's going to be a little bit of a, I don't know. There's going to be a little contention here in a minute about what you should do and shouldn't do. My belief, and I think everyone's belief should be, of course what I think, looking at this air handling unit enclosure casing, we've had, if you look at this part here, of course this is the dividing wall. This is like a plug fan. So on this side we have positive pressure, on this side we have suction pressure. We've got filter, coil. This says remove filters. You can or you can't. It's really irrelevant. So if we're going to test this section, we're going to test it in a negative, just like Troy said. We're going to test this section, it should be tested in a positive. Now the AABC standard indicates that you can do positive pressure all the way through if you tape up the exhaust. Well, there's a couple of problems with that. One, if you taped up the exhaust, you can't get out of the unit because you're stuck inside. If you tape it up from the outside and you pressurize this unit, the tape more than likely is going to blow off, or however you affix it. You can't really put something permanent on the outside of someone's unit with these suction doors, because then you'll be scraping it off with a putty knife to make his unit look pretty again. So I prefer to use the doors or the access points that, you know, turn out on your suction side rather than the positive.
So why inside the unit?
How are you taping up the doors on the, if you're going to pressurize it, how would you tape up the doors on the suction side if they all blow out?
Like, are you talking about measuring deflection?
No, no.
Inside, or
So what I'm saying is if you, well, let me go back to, so if we were to do this whole unit under positive pressure, and there was, let's say, an access door right here where number 2 is, and the access door came out, turned out to you, how would you seal that door if you had that whole thing under positive? Use good tape. Yeah, that's a possibility. But we're, you know, if we're going to test this unit, it's probably going to be at 6 inches.
What's the tape on the outside?
I'm sorry?
Tape on the outside and those tape off, you couldn't feel it.
Correct.
So when you put tape on the inside, you're going to mask it where you put that failure.
Right.
Will we-
So how do you tape it from the inside without, like once you tape it, you're stuck in the unit.
If you're positive and pressurizing the case, the tape would act as a sealant.
On the inside. Right, so if you're in there and you tape the door shut, how do you get out? That's my point is, you're kind of stuck.
So when it's operating, it's being sucked in, when you're testing, blowing it out, you're creating an operating condition, and it is going to be. That's why that, yeah.
And I was with Carrier, been with Train, been with Buffalo, and none of them were happy with doing their negative side under positive and the positive side under negative. They were not having any of that. We will adjust the doors, we will get it. And I was like, you know, that's fine. Go ahead, Gail.
How did you divide up the pressure when you did that?
When you say divide it up.
Did you test both sides at 10 inches? Or did you
Yes. So what we did here was, this was blanked off. There was a piece of sheet metal installed here to blank off, so we had a difference between there and there.
so you basically tested the unit to 20 inches.
If you want to say we tested that at 10 and this at 10, yeah. Yeah. Yeah.
People argue with that. Especially contractors.
Well, no one said anything about adding them together, so.
And we've had good luck taking off the doors that open out on the
Yeah.
suction side.
I'm not saying you couldn't, just saying I could see it being an issue. I would prefer to just have the unit act as it should in its environment rather than test it under something, because if you took the tape off, and as we found out with the Buffalo unit, those doors never really sealed tight, even with the suction on it. The suction wasn't enough to pull the gasket, the new gasket in, so he had to actually adjust the handles when he tightened down on them and actually pulled the door in to compress that gasket a little bit to act accordingly. I was quite impressed with some of the things they came up with.
Mike, when you did that, did the manufacturer put a plate over the fan, the inlet?
Right here?
Yeah.
Yes.
Okay.
Yeah, we had a plate there, a plate here, and a plate over the end. So we tested those sections. One of the unique things was he got in there with I guess you want to say a puffer, the wizard stick. I don't know if anybody has one of those. Everybody laughed. Do you know what a wizard stick is? No, yes. It's a little electric device. You put some fluid in, you pull the trigger, and it puts out vapor. Very safe, very awesome. It's a good piece. We use theatrical smoke a lot in these units. In this specific unit here, this rendition, we actually hooked up the theatrical smoke to the inlet of the fan because it was leaking, and they wanted to know where the leaks were. And I said, look, everyone, eyes open, because you're going to get about 45 seconds, and this whole room's going to be full of smoke. So pay attention to where this comes from. Unfortunately, we didn't video it at the time. We had too many people in there. It was a big party. And so what he found was, as the sealant was put around when these sections were put together, it may leak here, but then the smoke traveled all the way down. So everybody on the outside said, oh, the whole seam's leaking. Well, it wasn't the whole seam. So immediately they wanted to start running tape all the way across, all the way down, seal up the outside of the unit. And he said, if I get in here and we can get to this and I can inject my sealant in that area where I can see this coming, then we have to seal that little bit. The rest of the integrity seems good, we're good. It's pretty tricky, the way the guy went about it with his stick to see where it was coming in. And it held off the outside of the unit looking like a duct tape menagerie, every seam all the way around. You're like, wow. So unfortunately, the Dakin unit next to it, they weren't that concerned about the outside of their unit. That was all taped up. So we had a Dakin here and a Buffalo there. It was pretty neat. It was health science at University of Maryland. They were concerned about pipe penetrations and the neoprene that goes around them. What should be done with those? The neoprene was there. It got to 6 inches, and you could feel some air leaking out around it, so we just taped it up. There was nothing really we could do other than ask the manufacturer to send out different neoprene or isolation things around the piping to help correct that. Does anybody have any questions about air handling and enclosure in that casing picture? Go ahead. It was basically construction. This unit was put in up against the wall on the floor. Yeah.
But it was shipped in 4 sections, wasn't it?
It was shipped in 6 sections, yeah. Yeah. So all these little modules, and to be honest with you, this is part of the whole deal was, they were all like, when's the ship? When's the ship? When's the ship coming in? And everybody knows this. When's that piece shipping? When are those pieces coming? Well, they're on the truck. They're going to be here. And we've been at progress meetings. Oh, great. They'll be here Tuesday a week. Awesome. The rigger's there. They get them off. They throw them in. And it's put them all together. All right, there's the unit. It's up. And nobody took time to make sure it was put in correctly. They just wanted it, get it there, put it on the slab, housekeeping pad, get it together. And it weighs on me because it's such an integral part of the whole new building that you put together, that you just got all these pieces, slapped them in, the rigger's here, yeah, we got to get them done, nobody can wait, and the quality of craftsmanship went out the window. But ultimately through, I don't know, we were there 2 or 3 days, and it got done, but it didn't need to go that way. It could have been kind of if quality control was there, it would have been a much better situation. This is on the suction side of a unit. So I put this in here because this is a draw-through unit. That's just a discharge here. So everything here is under suction, okay? And this was at a project at Johns Hopkins. They had, they wanted it done under a negative. So I actually pirated this picture because it has some Spanish in here for bilingual. When we went under this, it was tough to find a piece of equipment that would go negative and hook up correctly. Seems like everything we could put our hands on was great to do positive pressure, but when you went to negative, the fan did not like seeing all that suction pressure and regulating it in the orifice tube. But we got it done, and it turned out rather well. But you can see by all these sections, we had 1, 2, 3, 4, 5. This is almost exactly like the unit we had, 6 sections. And they wanted to test this unit without anything hooked to it. The unit was set, put in place, it was outside. Don't touch it, don't drill a hole in it, don't put any EMT. We'll worry about that later. We have commissioning agents and everybody will be looking for all this penetration. We'll make sure they get sealed. Okay. Come to about a year or two later, they were wondering why all the conduit on the outside of the unit was sweating. Why does it look rusty? Well, nobody sealed it, and this conduit raceway, basically, on the outside of the unit, had cold air blowing through it all the time. Not a good thing. So I have a guy here putting a square peg in a round hole. That's basically what I think we're talking about here is we just had some people offer up ideas, problems, VAV boxes. It's about making good choices. Important to understand there are many differences between in-house and in-field recorded test data. I may have overlooked or I forgot to put it in here. If you go to the bottom here, it says the access doors in the negative section of the air handling unit can be taped because the seals are for a negative pressure or representative of the TAB agency shall witness the final test. That's what we were talking about earlier with the suction side, positive pressure side. Let me go back for 1 second. I think I glossed over something here. So in the AHRI, no, I didn't include it. I thought it was in here. In the AHRI standards, it simply states that in-house or in lab, in manufacturer's facilities, testing, they don't recommend trying to replicate that out in the field. For obvious reasons, but it's stated right in their standard that we're doing this in a fixed lab, perfect environment. Don't try to replicate this outside of here because it's not going to happen. Basically what they're saying. So when we got to this unit right here, it became a contention point. They wanted to go by, hey, we got this thing, perfect report that said this unit was leakage tested at the factory. University of Maryland and their people wanted it that way out here in the field, and it became a rough. So what they ended up deciding on this specific project was they wanted to test it at 6 inches. Well, the unit was never going to operate at 6 inches of static. Just never going to be there. It's going to operate somewhere in the 2.5 to 3. So my idea was let's diminish it by 6 to 5 to 4 to see if your allowable leakage on this thing is 300 CFM. Let's see what it does. We're leaking at 500. Let's go to 4 inches or 5 inches, find out what it's leaking there. Will you be okay with, we're tested higher than what you say the operating will be, but we're going to be within your leakage tolerance. It took a lot of meetings and a lot of, well, you got what you got, they're best they gun, and mechanical contractor threw his hands up. We put in the best we could. It's up against the wall, it's here. And they actually ended up forgiving some of it and saying, okay, we'll allow you to test it at 4 inches instead of 6, and we got it to pass. And it was about working with them. So at the end of the day, they got a better unit than they probably ever would have. Go ahead, Galen.
One of the problems with operating pressure, you need to look at where the shutoff head on the fan would be.
I'm sorry, say that again?
You need to look at where the shutoff head of the fan would be, what pressure you're going to be operating. Because that's really going to dictate that real pressure if you have a fire damper, set the fire damper shut real quick. now you've got a system really under static pressure. So that's something that everybody needs to consider, is quit talking about operating pressure.
Does everybody get that? So if everything on the system closed, this unit went to its maximum operating static, you know, we say it operates at 3, 6, well, that fan might be capable of going to 8. Hopefully the safeties are there, like they talked about there, we were at 3 inches. Hopefully the safeties work and we won't have a fancy round air handling unit. Or an imploded one. Room building pressure testing. Does anybody get into room building pressure testing? Myself, a couple other people. There's no brain surgery to it, but there is a lot of minutia to it with regards to temporary sealing of all the openings and areas being tested on your room or your building. There's many openings, many things where air can escape, and it can be very time consuming, very labor intensive. Anywhere from door jams, you know, the lock set in the door jam. Some people raising their hands, you know, wow, good bit of leakage there. When removing air from the negative pressure, then blowing air into the positive pressure, that's step 2. Step 3, the flow and pressure readings will be converted into an equivalent leakage area, or an ELA, the total area of all the cracks, gaps, and holes in the test room. The 2 readings are averaged into a formula. That formula will follow. The formula is equation for equivalent leakage area. Has everybody followed this or used this? You will if you ever start doing room building pressurization. I am no expert and I have very limited exposure to building or room testing, but I do know that there are many, the couple I've been to, there are many different opportunities to have errors here, many. Does anybody care to offer a instance of room or building pressurization case study or? Good, whatever.
Yeah, one of the issues that we discovered is you've got to be very meticulous in doing your area takeoffs, because, you know, a couple thousand square feet can impact your results. You know, if you miss a closet that's part of the enclosed space, or you know, things like that. So you've got to really go over your plans and then walk the site to make sure that you've accounted for everything that's on the plans that you know may have hidden lines that denote a empty space or a anterior space that's not necessarily part of occupied space, but it's a closet, it's a plenum or something like that. So you need to be careful about how you calculate that
Absolutely.
leakage area.
Yeah. We had a apartment building where they wanted to do the apartment testing, right? Well, they failed to give us the proper drawings, so when you went off of the 2-bedroom versus the 1 or the 3-bedroom, man, they didn't match what they had, and there were different closets, different room sizes. They weren't the 10 by 10s or 12 by 12s they were talking about. So you can't go off the plans. You got to be there, just like you said. Anyone else? Go ahead.
So do you just worry about the size of the space, or are you concerned with, let's say there's equipment in the room and it's filled, are you concerned with the volume of the room? Because it would be different if you had a room that was empty versus one that was full, if you're concerned with the volume of the room.
No, yeah. We're worried about the surface area. You're worried about the size of the room, not necessarily what's in it. Yep.
Hold on.
So how do you
That's
do a
ironic.
whole building test, let's say a high rise in wintertime, or anytime, I guess? How do you do, first that question, how do you do a whole building?
That's a question not from me.
Okay.
I wish I could answer it, but I wouldn't stand up here and guide you. Maybe Troy could give you some of.
I think in that case, you're gonna have multiple fans at all your exterior points, even including like roof access. If you have multiple fans, pressurizing the building from different points because we don't want to have much difference floor to floor. So we can place fans at stairwells to equalize pressure. We can place fans at roof hatches to bring air from the top and air from the exterior doors on the ground floor, things like that. That you would try to equalize pressure throughout that building.
So keep the mic and just repeat my question. So how do you do the biggest building? No, keep the mic. He's going to answer it. What's the biggest building you can do effectively?
You have to compartmentalize probably.
So the
It's all
question,
dependent on the size and amount of lower door tests that you have. So you're going to ballpark what your leakage for the building is allowed to be, and you're going to figure that out, and you're going to see, you know, if you have enough fan capacity, you can do as big a building as you want.
Back to Mike.
But you're probably going to have to compartmentalize on a large high-rise building.
So do you take a low-rise, mid-rise, high-rise, and average them? You know, because the building's
You have your surface area of what you're establishing for your leakage for that area that you're testing, the area under test.
My base word is, you know, building under stack effect, the low, mid, and highs would be totally different from each other. So you,
I'm sorry?
when you do a high-rise,
you need 2 lines.
Yeah, if you do a high rise under building stack effect, the low, mid, and the higher could be totally, you know, dramatically different on impact. So do you do a sample on the low, mid, and high and average them, or how do you do something like that?
You're
Just
pressurizing that one section. So let's say you do the low first.
Right.
And you get that first 5 floors, 10 floors, whatever your fan capacity can do. You're testing that 2-way pressure, typically 50 or 75 pascals, and you're looking for a volume of airflow that you're allowed to leak at that pressure. So once you do that section, you're going to say, okay, it passed or it didn't pass. Now you're going to look for what you're leaking, what you're going to seal. Once that section passes, then you go to your next section. So it's each test section. Just like if you took an air hammer and you did your negative section, you passed that section, then you took your positive section and passed that section. It's each individual section of the test. You're not going to combine it all as one test.
I think hypothetically, we could test the whole building. We just have to have fans inside.
Yeah, if you had enough,
pressure
if you had enough fan to test the whole building, then yeah, you can do it.
And so we can equalize the pressure between spaces, and we've got monitoring points throughout.
Yeah.
And we're just going to keep moving that pressure, moving that air through the resistance until we equalize the pressure all the way, wherever the entry point is.
You're trying to identify that leakage in that area.
That's why we want to have the pressure coming in from all directions as much as possible from the exterior, so that there's minimized, you know, effect from floor to floor. But ultimately, yes, there's a range that we have to hit within tolerance to maintain that pressure throughout.
I will offer this, Retrotech, and I'm not a, you know, this is not a paid for advertisement. Retrotech is wonderful. They're great people to call. They're great people to consult. They've been doing this for a while. They put out a great product, in my opinion, and they'll help with anything you have there. And they'll even, you know, kind of help you design a program for something like that in a high-rise building or a multi-level building. One thing I wanted to get to before, I guess we wrapped it up here. Do you guys see this top note here? And I want to see some weird faces out there, specialized tests, sewer. So we had an occasion, this is just an anecdote I'm going to give you, in a simple project we had. We had an engineer buy a brand new building, a 3-story building, boom, boom, boom. On the second floor, he had sewer gas smells. Didn't know where they were coming from. Second floor. Third floor was all rooftop units, outside air, boom. First and second floor were regular fan coil units. They had an outside air coming into each one, little gooseneck coming down, ran down the building. They had general tooled exhaust. So we did a little bit of evaluation of the building. It was a little negative. We're like, where's the sewer gas coming from? Man, it's the smell. Some days it was worse than others, depending on humidity, outside temperature, stack effect, I guess, in the building, whatnot. So in our think tank at the office, we came up with this idea to take the little Cadillac blower that we had for the small leakage test system we have, and we hooked it to the vent pipe on the top of the building. And we thought maybe there's a vent pipe in a chase, in a wall somewhere that hadn't been hooked together, still open, you know, maybe expunging a whole bunch of sewer gas smells in there, and then it gets leaked into the building. So maybe if we hook this pressure tester up, pump a little theatrical smoke into it, get that other side of the sewer system, if anybody knows how they work, the plumbing side, should be the other side of your traps. Smoke started coming out of the other vent pipe on the roof. We're like, wow, well that's good, it's hooked together, right? Seal that off, put some more smoke in it. So then we're looking off the building. Well, there's nothing coming out of the street sewer drains or manhole covers. Guess that's good. Go back in the building, we have people walking all around, ton of smoke. I mean, we had a ton of smoke going in this thing. Finally, we go into the bathroom on the second floor, women's room. 5 toilets, flange to the floor, not to the wall. All the traps are in the toilet, correct? All the flanges had smoke just coming out around them. We're like, oh my gosh, room's filling up with smoke. What is that all about? Had the guy start pulling toilets off. They didn't put wax rings in any of the second floor toilets. All 5. Whoever did those that day had a rough night before, forgot to put wax rings in all of them. And it kind of curbed the problem. So I don't know what the best formula for leakage testing coordination success is, but I do know it's coordination and communication, and it has to do with quality and integrity. And if you get a team together and you're on a project, push, 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 make it happen. What are the other recommended standards? What are the recommended standards and methods? I think it's clear that we're going to stick to the AABC standards and methods. How should deviations be handled? How can further testing initiatives be implemented? We talked about plenty of those today with smoke testing, sectioning, taking, suction plenums and not testing them under positive plenums, not testing them under negative. Does anybody have any questions or other comments? Okay, go ahead.
What fan did you use to get negative situations?
We borrowed a fan from a competing air balance company who had one that was, I want to say it was 5 horsepower. It was a big older, they don't use it much. It had a 12-inch orifice plate. It's a big one. They had to have run 220 to it. It was intense, to say the least. Thank you all, I appreciate it. I hope you learned something today, and enjoy the rest of your time.
Thanks very much, Mike.